Okay, in the previous videos, we moved into animation from the for loop drawing our square. So I just want to kind of start again and look at what's called bounded motion, right? So to start this one off, let's save a copy of our m6.js, right? And I'm going to just call this m6 square, right? Because this is where we're drawing the square in various ways. So I'm going to save that as square and then go back to, right now I can even close that, go back here and let's just get rid of the code we don't need. So I'm going to get rid of this for loop that we had commented out. I'm going to get rid of the update data. We'll create a new one of those and let's get rid of that code there. Right, so we have our shape, we have our rectangle, circle, Randy, right? So we're sort of starting again. Let's and actually get rid of our object. Okay, so what we want to do is we want to randomly place our shape on the screen and then move it in a line. Right, so we're using the same principles that we've used in the previous video. We're just starting from scratch and not moving from the for loop, right? So let's create our variable O1, right? So in this, we're going to need our X coordinate, right? So let's say random W, right? So we'll randomly put it on the screen, create a Y coordinate, random H. So we'll randomly choose, use our random function to choose our XY coordinates. We are going to need a change in X, right? So let's just set this to 10. We will need a change in Y. Let's set that to 10 as well. We will need a color. So let's do purple again. And let's do rand 360 just to use our random number, and an alpha of 1. And I think, oh, and we do need, for drawing the squiggly, right? We do need an S, a size. So let's create an S of let's try 50. Okay, so does that give us everything we need? X, Y, we need a number. We need N, let's do 6. And then let's just make sure this is all working. So we want to pass O.1. Okay, there we go. I'm going to change this random color and let's just do purple just because, right, so we always see it. Okay, so we have a randomly placed shape on the screen, right? This could be a circle. You would just need to set up your O1 with the right properties to suit it, right? Again, we want to pass an object to it, so we would need to update these. I'm not going to worry about that at the moment. If you're wanting to use a circle or rectangle for this, just make sure you update your rectangle and circle function. Okay, so we have our object, we have our draw shape, we're passing it an object, right? Okay, so what we want to do is we want to move it in some direction, right? So if we think about this, this will move down and to the right because they're both positive, okay? So let's just work with that for the moment. So we need to create a function. Well, actually, you know what? Before we do our update data, let's create a variable for loop, set interval. Let's make an animation loop set it to 30 milliseconds. So we need to create a function, animation loop. And at the moment, we're just going to be drawing squiggly to the screen. Oh, set interval. Actually, let's just see. Did we get an error? Yes, we did. Perfect. All right. Okay. So here we are. We're drawing this to 1 point on the thing. So that should make sense. That's what we ran into previously. So now we want to create our function update data. It will take an object. And what for this, all we want to do is say o.x plus equals o.dx. o.y plus equals o.dy, because we just want to move it. So here we're going to do update data 01. Okay. Right. So we're using set interval. We've set it to 30 milliseconds. So now, right, we have it moving in a direction, right? And you'll notice it always moves down to the right because we've passed it 10 and 10 for our change in X, change in Y. So let's just say we wanted to randomly choose its direction, right? So we could say rand here. But if we do this, we're still going to be going down to the right to some degree, right? Based on the value that those random functions get, right? So let's create a random function that gives us a probability of a negative number. Because right now, both our random functions are only positive. But here, if we want to go left or want to go up, we need a negative number. So let's create a function, rand_n, right? Because rand_n just for a random number, that negative number, right? We need our variable result. So we want to say math.random multiplied by the range. And what we're going to do, like if you think about our range at the moment goes from 0 to whatever argument we pass. So if we pass, our random function's 10, we go from 0 to 10, right? So what we're going to do is use that range and just shift it down. So instead of 0 being the low value, the lowest value possible, 0 will be the middle, right? So our range will go, if it was a range of 10, instead of being from 0 to 10, it would be -5 to 5, right? And if it was 100, it would be -50 to 50, right? So the range is the same. It's just 0 ends up being in the middle. And we do that by, if you think about it, if we have 10, we go 0 to 10. That's our range. And what we want is to shift that down by 5. Right? Because we want, instead of 0, we want -5. Instead of 10, we want 5. So all we have to do is go take away r divided by 2, right? And this will shift everything down half the range, meaning 0 will be in the middle. So we do that, and then we return result, right? So now we have a random, we have our straight up random that returns a float number within that range. We have a random number that returns an integer that we have used for arrays because they need an integer. And now we have a random number that its range includes negative numbers. So you have a 50-50 chance of it being negative or positive, right? So now let's go back to our object and change these from rand to rand_n. So we save that, go back, right? And now, right, see, we're going up. Right, so now we have the chance, not only are we randomly placed, right? We have the chance of going in any direction. So just to make this a little more clear, let's go to the center of the screen. So instead of being randomly placed, let's go to the center of the screen. So I'm updating the X and Y coordinates to be the center of the screen, right? So now we're always starting from the center. We can see we can end up going in any direction. And based on the magnitude of these numbers, will determine the speed, or partially determine the speed in this case. Here, if we lower this, right, it will go faster, right? So we have, with set interval, we can affect the speed that things happen with our interval, but dx, dy, change in x, change in y, also affect the speed. The higher they are, the more we move each iteration. Okay, so at the moment we can move in any direction, right? So perhaps we want to say at least go 3, right? You're at least going to move 3 pixels, and then we'll add 10, right? So it has a speed. Okay. So a couple of things. At the moment, we have a partial animation loop, right? We're drawing to the screen, we're updating data, we're drawing to the screen. And, you know, a true animation loop, we need to clear the screen, right? So let's create that function. So I am going to do this just above squiggly. This is just a small little function, right? So we're going to declare a function, call it clear, and all it's going to do is clear the screen. So there's a simple method that allows us to clear a rectangle, right? And we give it the top left coordinate and the bottom right coordinate, right? So we can clear part of the screen with this clear rect. But what we want to do is clear the whole screen. So we want to start at 0, 0 and go to WH, because we want to clear the whole screen. So here, right, and we want to think about this. If we put clear down here, what do you think would happen? Right? Right? So at the moment, we don't see anything. Because if you think about the animation loop, this is being called every 30 milliseconds. So, right, the function is called. So we draw, we update, we clear the screen, we wait, 30 milliseconds minus the time that took, right? So 30 milliseconds or, 29.99 milliseconds, whatever the actual speed of what that takes. So it's actually being drawn to the screen and taken away so quickly we don't see it, right? So we need to make sure that we clear the screen at the beginning of our animation loop, because we want to clear the screen, draw, update our data, wait. Clear the screen, draw, update our data, wait. Right? So now, right, we definitely see which point is our position, because it's the point that moves. Right? So now we have a type of animation loop. Right? So here we're really getting into an official animation loop, where previously we were playing with drawing to the screen and having that happen dynamically. And again, that depends on clearing the screen, right? So we can choose when we clear the screen, play around with that. But for animation, really, you want to be clearing, drawing, updating data, wait. Clear, draw, update data, wait. Okay, so here we have our shape that moves across the screen, right? So now let's set it up where it's bounded to the screen. Right now it goes off the screen and just continues on. Where we want to bound it to the screen, and we're going to look at 2 ways. We're going to bounce, where if we hit the edge, it will bounce back. And what's called toroidal navigation, where, and you've played in some of the games you've played, where if you go off the screen, you show up at the opposite end, right? So if you're going up, you'd come back and go back. So let's start with toroidal bounds, right? So let's create in our update data function, we want to create an if statement where we say if O.x is greater than the width of the screen, do something, right? So if it's greater than the width, we want something to happen. What do we want to have happen? We want it to go in the opposite direction. So we want to change our dx. So we'd say O.dx, right, multiply equals -1. Because this will take whatever dx is, right, whatever this random number is, and it will make it a negative. And if it's negative, we'll multiply by -1. It will make it positive. So this will swap the direction. So let's just see if we can get this to happen. There we go. And of course, okay. So we see that it changes the direction, and now it goes off the screen on the other side, right? So we could create another if statement saying if O.x is less than, right? Let's see if we can get this again going. There we go. So it bounces. Will we see it on this side, or will it be below? Right, we can see it bounce there, right? But if we think about this, we're doing the same, right? We're wanting the same thing to happen whether it's greater than w or less than 0. So instead of creating a whole different if statement, we can say if O.x is greater than w, or O.x is less than 0, right? Because 0 is that the left-hand side of our screen, then do this, right? And then if O.y is greater than h, or O.y is less than 0, right? O.dy, multiply it by -1. Right? And set that value, right? So here, just to clarify again, O.dx equals O.dx multiplied by -1. I'm just putting that in brackets, right? So this is the shorthand. Like when we had plus, right? Same thing, now we're just multiplying. Whoops. Right? So you could write it out like this. But again, this is the shorthand for that. So let's just take a peek. So here we're actually, you know what, let's make this go faster just for this. Of course, that's going to make it go down. Let's just increase this, our chances of it going faster, right? Boom, boom, boom. Right? So, okay, I think I said we were going to start with toroidal. Clearly, we're starting with bounce. Notice that it is the position coordinate that we see bouncing, right? So that it disappears there, it disappears there, there it doesn't, because it's the top left corner here, right? Okay, so that's the bounce, right? So we could create a function, call it bounce. It's going to take an object, and then essentially we would just put this code in there, save it, and then if we wanted it to bounce, we could pass it O. And I'm just doing this because we're gonna, oh, I put 0, of course, that's not 0, that's a O, right? Bounce, bounce, bounce. Now, I'm just doing this because we're going to swap out and create another function called toroidal. It's going to take an object, and in this case, if O dot x is greater than the width, O dot x equals 0. Right? So if O dot x is less than 0, O dot x equals width, and then so on. If O dot y is greater than the height, we want to set O dot y equal to 0, right? And let's just think about this, right? Because in this case, we're bouncing, so we're changing the direction. In the other case, if y becomes greater than the height, set y back to 0. Okay. And then lastly, if O dot y is less than 0, set O dot y equal to h, right? Okay, and then let's swap this out, toroidal, and let's see how this works, right? Perfect. So now, and this is what we'll look in the next one, what if we wanted to have a lot of shapes on the screen, right? How would we handle that? So I'll stop there for this module.